Welcome to this part of the electromagnetic neurotechnology video series, where we will explore the latest advancements in neurotechnology devices. This section will cover a range of technologies designed to enhance, interface with, or even replicate brain functions. We will begin by discussing brain-supporting technologies such as virtual reality, VR reality, AR, which enhance sensory perception and cognitive capabilities without directly interfacing with the brain. Next, we will move on to neurotechnology that interacts more directly with brain functionalities, such as brain implants and brain-machine interfaces, BMIs. These technologies establish direct communication pathways with external devices, offering new possibilities for medical treatment, cognitive enhancement, and human-machine integration. Following that, we will delve into cyborg-oriented neurotechnologies, which involve deeper integration between biological and artificial systems. These advancements push the boundaries of human enhancement by merging neural activity with power. Finally, we will explore the ambitious frontier of neurotechnology, virtual brains, and mind transfer projects. These include efforts to simulate human consciousness, transfer mental states into digital systems, and create brain emulations that could potentially redefine human identity. And we begin our exploration with virtual reality, a technology that does not rely on direct neural interaction, but instead influences the brain through immersive sensory experiences. VR creates a simulated environment that stimulates the visual and auditory senses, providing an illusion of presence in a virtual world. This technology is widely used, including entertainment, education, therapy, and training. By manipulating sensory inputs, VR can alter human perception, enhance learning experiences, and even contribute to neuroplasticity by training the brain in simulated environments. Virtual reality serves as a brain-supporting device that enhances cognitive and sensory directly modifying neural structures. Visual enhancement, VR can improve spatial awareness, reaction time, and cognitive flexibility by providing controlled and immersive visual experiences. Cognitive training, applications in neurotherapy and rehabilitation use VR to assist patients recovering from neurological disorders, such as stroke. Adaptive cognitive exercises. Sensory substitution. Some VR-based technologies aim to compensate for sensory impairments by translating one type of sensory input into another, such as using tactile feedback to assist visually impaired individuals. While VR does not directly interact with neurons, its impact on neuroplasticity, learning, makes it a fundamental stepping stone toward more advanced neurotechnology. Augmented reality is a brain-supporting technology that enhances perception by overlaying digital content onto the real world. Unlike virtual reality, which immerses users in a fully virtual environment, AR blends digital elements with physical surroundings in real time. AR enhances visual, cognitive, and interactive experiences without directly train. It is used in education, medicine, industry, and assistive technologies to provide real-time contextual information, improve spatial awareness, and reduce cognitive load. Visual augmentation, AR, displays holograms, data overlays, and navigation cues, improving real-world interaction. Cognitive assistance, time analytics, object recognition, and interactive simulations, AR aids in learning and decision-making. Practical applications, AR enhances surgical precision, industrial training, and accessibility for individuals with impairments. Though AR does not modify neural activity, its external cognitive enhancement plays a crucial role in bridging human perception with digital. As we move deeper into electromagnetic neurotechnologies, we explore the cutting edge of brain interfacing systems, brain implants designed for both recording and stimulation. Unlike external sensors such as EEG or even invasive ECOG electrodes, these implants establish direct interaction with neural circuits, capturing and modifying with unprecedented precision. By detecting local field potentials and high-frequency neural spikes, they provide real-time insights into cognition and neural dynamics. Beyond recording, electrical and magnetic stimulation techniques enable the modulation of neural networks, offering treatments for neurological disorders and even cognitive enhancement. Further, the concept of a virtual brain emerges, where brain activity is digitally modeled and simulated through AI-driven emulation, bridging biology and computation. This shift toward neurodigital integration opens the door to even more ambitious possibilities, such as mind transfer technologies. By leveraging brain-machine interfaces and wireless neural communication, researchers are beginning to explore ways to store and process thought patterns beyond the biological brain. The prospect of brain-to-brain communication and consciousness emulation challenges our understanding of identity and cognition, hinting at a future where the human mind is no longer confined to the physical brain. As these technologies redefine the boundaries of perception, intelligence, and self-awareness, bringing us closer to an era where electromagnetic neurotechnologies reshape the very nature of consciousness. As we push deeper into the frontier of electromagnetic neurotechnologies, brain-machine interfaces, BMI, emerge as the most advanced form of neural integration, bridging the gap between biology and technology. Unlike simple implants, BMIs are full-system architectures capable of recording, interpreting, and stimulating brain activity. These systems leverage invasive and non-invasive technologies to establish direct communication between the brain and external devices, enabling complete cognitive and motor tasks. BMIs operate through sophisticated neural implants, decoding electrical and electromagnetic signals from the brain to control robotic limbs, digital interfaces, artificial intelligence. Advanced stimulation techniques allow for bidirectional feedback, enhancing sensory perception, restoring lost functions, and even augmenting human cognition beyond natural limits. By seamlessly integrating with the brain's electromagnetic activity, BMIs hold the potential to revolutionize everything from neuroprosthetics. The ultimate vision of BMI technology extends beyond assisting those with disabilities, toward a future where humans can directly interface with machines, share thoughts without words, and even merge biological consciousness with artificial intelligence. This is the foundation of an era where the brain is no longer confined to the body, but extends into the magnetic realms, redefining what it means to be human. Cyberorganisms mark a revolutionary leap in human evolution, blending biology with cutting-edge neurotechnology. These hybrid systems integrate brain-machine interfaces, artificial intelligence, and advanced robotics to push beyond the natural limitations of the human body and mind. By creating a seamless symbiosis between neural activities, cyborgs pave the way for enhanced cognition, sensory augmentation, and even direct brain-to-cloud connectivity. This transformation is not just about interfacing with machines, it is about redefining what it means to be human. One of the most ambitious pioneers in this field is Neuralink, a company dedicated to developing ultra-high bandwidth brain implants. Neural threads are designed to enable seamless communication between the brain and external devices, restoring lost motor functions, enhancing perception, and even unlocking new cognitive abilities. Neuralink's system is not merely a tool for treating neurological disorders, it represents the foundation of a future where humans can interact with technology. Looking ahead, Neuralink envisions a world where brain interfaces go far beyond medical applications. With full-brain AI integration, the possibilities extend into telepathic communication, memory expansion, and real-time access to vast digital knowledge. Imagine a reality where thoughts can be transmitted instantly, where knowledge is up consciousness, and where human intelligence is no longer confined to biological limits. This is the ultimate vision of cyborgs, a future where mind and machine converge into a new form of existence, unlocking potentials that were once the realm of science. The virtual brain represents the next frontier in electromagnetic neurotechnology, where the fusion of brain-machine interfaces and advanced neural recording techniques enables the complete digitization of the human brain. By continuously capturing and updating neural activity through brain implants and BMI systems, we move closer to constructing a full-scale biological brain. This virtual brain is not merely a static map, but a dynamic, evolving model that replicates real-time brain function, integrating both anatomical structures and physiological processes. At the core of this concept is the ability to compare and synchronize the virtual brain with its biological counterpart. By analyzing neural responses and sensory feedback, we can refine the digital model to mirror the behavior and processing patterns of the real brain. This continuous update cycle ensures that the virtual brain reflects not only the static architecture of neural networks, but also the fluidity of thought, emotion, and memory formation. This level of neural simulation lays the most ambitious goals in neurotechnology, mind transferring. A complete, real-time virtual representation of the brain is a fundamental requirement for preserving consciousness beyond the biological form. The ability to map, store, and reconstruct the entirety of an individual's neural processes brings us closer to a future where cognition can transcend, unlocking the potential for digital immortality. The virtual brain is not just an extension of neuroscience, it is the bridge to a new era of human existence in the digital. As we stand on the edge of the neurotechnological revolution, mind transferring represents the ultimate frontier, a future where human consciousness is no longer confined to the biological brain. By building upon the virtual brain, advanced brain-machine interfaces, and real-time neural mapping, we are laying the groundwork for a world where thoughts, memories, exist beyond the limits of the body. Imagine a future where the mind can be preserved, enhanced, or even transferred into new forms of existence, breaking the boundaries of life as we know it. But this journey is filled with immense challenges. The hardware, ultra-fast processors, high-fidelity neural interfaces, and human-like robotics must evolve to the complexity of the brain. The biggest question remains, can we truly transfer consciousness, or are we simply creating a digital reflection of ourselves? And how will AI shape this future? Will it enhance human intelligence or redefine what it means to be human altogether? Despite these challenges, the vision remains clear. The fusion of neural intelligence and cutting-edge technology is bringing us closer to a world where the mind is no longer limited by biology. Whether it leads to digital immortality, enhanced cognition, or a completely new form of human existence, one thing is certain, this is just the beginning of an extraordinary journey into the future. Thank you for watching. Stay tuned for more deep dives into the future of the brain, mind, and technology. Don't forget to like, subscribe, and join us on Electromagnetic Brain, Unlocking Consciousness to stay informed about the latest breakthroughs in neurotechnology.